So solutions are homogeneous mixture of two or more components. So the components present are solute and solvent. So concentration described by mass percentage is commonly used in industrial chemical applications. So what is mole fraction? It is defined as the ratio of number of moles of a particular component to the total number of moles of your solution. Molarity is equal to number of moles of solute, which is represented by N, divided by volume of solution in liters. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with the session 5, the last session for your chapter, Some Basic Concepts of Chemistry. So in last session, we discussed about mole concept, molar mass, percentage composition, empirical and molecular formula, right? So in today's class, we'll be discussing on stoichiometry, limiting reagent and reactions in solutions. Okay, so let's begin with the first topic, that is stoichiometry. So what exactly is stoichiometry? So let's take an example from your day-to-day life itself. Okay, so let's say that you love coffee. Okay, so your mom prepares the best coffee. It's not just that you have coffee from home, right? When you go outside, you have coffee from there as well. But wherever you have tasted the coffee, the best coffee is the one which your mom prepares. Why is it? The ingredients are same everywhere, right? It is coffee powder, milk and sugar. Yes, anywhere you go, the ingredients are same. Even your mom is preparing it with the same ingredients. But still, the taste with which your mom prepares is just perfect. Why is it that? See, the proportion of the ingredients that she is adding is perfect, right? It is the right amount of sugar and a right amount of coffee powder, right? That is why it is perfect. Okay, so let's come back to the chemistry side of it. What is stoichiometry in the case of chemistry? See, it deals with the calculation of masses of reactants and products involved in a chemical reaction. So stoichiometry helps us in finding exactly how much quantity or how much mass of reactants is required to produce the required amount of products. So using stoichiometry, you will be able to calculate the masses of reactants and products so that you will get your perfect chemical reaction. So what exactly are you doing in stoichiometry? How do we obtain this masses of reactants and products? Using balanced chemical equation. Yes, regarding this, you have already studied in your 10th class, right? How do we balance a chemical equation? Yes, so what is the need of balancing an equation first? Yes, according to the law of conservation of mass, your mass of reactants must be equal to the mass of products. Right. So let's take an example and understand this concept. Right. So we are going to balance the chemical equation for the complete combustion of methane. So what is the equation? Methane reacts with oxygen. Combustion reaction is taking place. Right. It gives CO2 and water. Right. Now, is this a balanced chemical equation? So how do you balance a chemical equation? The number of atoms of each element must be equal in the reactant side as well as product side, right? So let's see here. Carbon, only one atom here. Here also carbon is one. No problem. What about hydrogen? 4 here and 2 there. So what can I do? I can add a 2 here, right? So this becomes 4. Now let's balance oxygen. Here it is 2. And what about there? It is 2 here and 2 in this part, so it will become 4. Now I have to balance it in here, so I can just add a 2 here. Yes, so now I obtained my balanced chemical equation. Now using this, we will be able to gather a lot of information. So let's see what and all information you can gather from this particular balanced chemical equation. So can I say that 1 mole of CH4 combines with 2 moles of oxygen. So here there is no stoichiometric coefficient. That means it is 1, right? So 1 mole of your CH4 combined with 2 moles of your oxygen to give 1 mole of carbon dioxide and 2 moles of water, right? Yes, you obtained this one from here, this information. So in the terms of molecules, how can I write? 1 molecule of CH4 combines with, yes, it is 2 here, so 2 molecules of oxygen to give, yes, 1 molecule of carbon dioxide and, yes, 2 molecules of your water. Yes, so you understood in terms of moles and molecules. Now we can also write it in the form of your mass, right? So how much CH4 is present here? What's the molecular mass of CH4? You know how to calculate it, right? CH4 means it is 12 plus 4, which gives you 16, right? 16 gram of your CH4 reacts with, yes, 2 into 32 grams of oxygen to give, yes, what is the molecular mass of carbon dioxide? Yes, it will be 12 plus 32, right? So 44 grams of carbon dioxide and 2 into 18 grams of water. Yes, from balanced chemical equation, you will be able to obtain these informations. I hope it is clear. The stoichiometry part is clear for you. Now, let's move on to the next part, that is limiting reagent. Now, what is limiting reagent? So, in case of a certain chemical reaction, what happens is, you know that two reactants combine and forms products, right? So, in certain cases, in certain chemical reaction, what happens is, one of your reactants will be present in lesser amount. So, as the reaction proceeds, what happens is, the reactant which is present in lesser amount gets consumed first. So, now there is no reactant, that reactant which was present in lesser amount is not present there. Only the reactant which was present in more amount is present there. So, what happens? Your chemical reaction will stop happening, right? So, because of the lesser quantity that is present, yes, your chemical reaction stops happening. So, that particular reactant is called as your limiting reagent. So, let's see, the reactant which gets consumed first limits the amount of product formed and it is known as limiting reagent. So, let's see here, in a chemical reaction, the reactant which is present in lesser amount gets consumed after some time and then further reaction does not take place even if the other reactant is still present in more quantity. Hence, this limiting reagent limits the amount of product that is formed. So, let's take an example. These are my reactants and it gives a product C. Okay, so I am supposed to have 10 grams of A and 20 grams of B so that I get, yes, 30 grams of C, right? Yes, this is what I am supposed to have. But what happens is, the chemicals that I have now with me is just 8 grams of A and I have 20 grams of B. So, can you tell me which will be the limiting reagent here? I am supposed to have 10 gram, but I only have 8 gram here. So, yes, your A will be your limiting reagent. Understood? Even if B is present in the exact amount, A is getting consumed. So, what happens? Your chemical reaction will stop happening. Clear? Yes. So, how can you expect questions from this part? Let's take an example. In a reaction, A plus B2 giving AB2, identify the limiting reagent in the following reaction mixture. So, your chemical reaction is given here, that is A plus B2 gives AB2, right? So, in the last topic we studied, when we studied stoichiometry, now you know that how you can obtain informations from this balanced equation, right? Is this a balanced equation? Yes, it is balanced equation. So, now the first part is, when 300 atoms of A and 200 molecules of B reacts, you have to find out which among these is the limiting reagent. So, from the equation that is given, what information can you obtain? It is in terms of atoms and molecules. So, let's see. So, for one atom of your A, there must be one molecule of B, right? Yes, you can see it is B2 here, 2 atoms. That means one molecule of B2. Yes, there are no stoichiometric coefficients in here. So, one atom of A gives you, that is one atom of A needs one molecule of B. So, what is the question asks? 300 atoms of A and 200 molecules of B. So, if it is 300 atoms of A, that means you need to have 300 molecules of B, right? One atom of A requires one molecule of B, means 300 atoms of A requires 300 molecules of B, right? But how much is present here? Only 200 molecules is present here. Yes, so what will be my limiting reagent in this case? It will be my B, right? Yes. Now the second one, 2 moles of A and 3 moles of B. In terms of moles we are considering in here. So yes, from the same equation, how can I write? 1 mole of A requires 1 mole of B, right? If I am writing both in terms of mole, it requires 1 mole of A requires 1 mole of B. So in here it is 2 moles of A and 3 moles of B. So whenever you do numericals based on this, consider which one is the higher one. You have to consider that one. See, it is 2 mole and 3 mole here. Begin with the value which is higher. So I am beginning with 3 moles of B. So what does that mean? If I am having 3 moles of B, I require how much? Yes, 3 moles of A is required, right? Yes, 1 mole requires 1 mole of B. So 3 moles of A require 3 moles of B, right? Now what is given here? Only 2 moles of A. Yes. So what is my limiting reagent here? It is A, right? Now the last one, 100 atoms of A requires 100 molecules of B. You have to find the limiting reagent. So let's take the first part itself. 1 atom of A gives you 1 molecule of B. Yes. So 100 atoms of A will need how much? Yes, 100 molecules of B. Yes. So in this case, there is no limiting reagent. Both are present in equal quantities which is required. Yes. So I hope the limiting reagent is clear and how to do the numericals. Now let's do one more question on this. How many moles of CH4 are required to produce 22 gram of CO2? So this type of question also you can expect. So this is the equation that is given. You have to find out how many moles of CH4 are required to produce 22 gram of CO2. So let's see how to proceed with this numerical. So the balanced chemical equation is already given here. So what information you can obtain from here? We need to find out the relation between CH4 and CO2. So we are considering. So how do I proceed? 1 mole of CH4 will give me how much? Yes. In terms of gram, I am writing for CO2 and in terms of mole, I will be representing for CH4. So that is what is required in the question. Yes. So 1 mole of CH4 will give me 44 grams of CO2, right? Yes, 44 gram. Yes, there is no stoichiometric coefficient in here. So it is just 44 grams. So where did this 44 come from? 12 plus 32 will give you 44 grams. Yes. So 1 mole of CH4 requires 44 gram of CO2. So I'll write it in the opposite way. So it is easy for you to calculate. 44 gram of CO2, 1 mole of CH4. Okay. So in the question, we need to find out the number of moles of CH4 that are required to produce 22 gram of CO2. So if I need 22 gram of CO2, what will be the number of moles? It's basic calculation. It will be 1 divided by, this comes here, multiplied by 22. Yes. So what it will be? It will be 0.5 moles. Right? So you require 0.5 moles of CH4 to obtain 22 grams of carbon dioxide. Yes. I hope it is clear. Now let's move on to the last topic of your chapter, that is reactions in solution. So before beginning with the topic, you need to know what are solutions. So solutions are homogeneous mixture of 2 or more components. So the components present are solute and solvent. Yes. So you know that solute combines with your solvent and forms your solution. Right. So it is important to understand the concentration of a solution. So let's take the example where I take a glass of water. I add 1 spoon of sugar to it. I mix it thoroughly. I get my sugar solution. That's the case. Now I am adding 2 more spoons of sugar to it and I mix it thoroughly. So I can say that the concentration of the solution increased. Right. So instead of sugar, I am adding more water into it. I can say that my solution became more diluted. So how are you able to say that now it is concentrated or diluted? It is based on the amount of solute, right? So what is concentration of a solution then? It is the amount of substance present in its given volume and can be expressed in the following ways which we are going to study. So it's basically the amount of substance, that is the amount of solute present in a given volume of your solvent. right? So there are different ways in which you can express this concentration terms, or you can calculate your concentration, right? So we will be studying about 4 terms here, that is mass percentage, mole fraction, molarity and molality. Okay, so these are the 4 ways in which you can calculate the concentration of your solution. So let's begin with the first one, that is mass percentage. So as the name suggests, it will be something related to mass, right? So let's see. So the mass percentage of a component in a solution is defined as, yes, mass percentage, how you can calculate it is the mass of component in the solution by total mass of the solution multiplied by 100. So the example that we have taken before, that is your sugar solution, you need to find the concentration of the solution. Yes, in terms of mass percentage if you want to see. So you have to use the mass of sugar that you have added divided by the total mass of your solution multiplied by 100, which will give you the concentration of the solution in terms of mass percentage, right? So for example, let's say if there is 10% of aqueous solution of glucose by mass, okay, if it is given that 10% of glucose by mass, what does that mean? It means that there is 10 gram of glucose which is dissolved in 90 gram of water, resulting in 100 gram of your solution. So 10% glucose by mass, that means 10 gram of that will be your solute, yes, and 90 gram will be your solvent, which gives you a total of 100 gram, right? So you know that mass of solute plus mass of solvent will give you mass of solution. So 10% means 10 gram solute, 90 gram solvent, which gives you together 100 grams of your solution. Clear? Yes. So concentration described by mass percentage is commonly used in industrial chemical applications. Yes. So I hope this is clear. Now let's do an example, that is a question for this. So you'll understand it better. A solution is prepared by adding 2 gram of a substance A to 18 gram of water, and you have to calculate the mass percentage. So what is the equation? How you can find out mass percentage? Yes. So instead of writing it at mass percentage, you can also represent it as W by W percentage. What is this W? W is the mass, right? Yes. So that will be equal to the mass of the component by total mass of the solution multiplied by 100, right? So a solution is prepared by adding 2 gram of the substance. So that is the mass of your solute divided by, yes, and a substance to 18 gram of water. So what is given here? Is it the mass of solvent or mass of the solution? Mass of solvent is given as 18. So what will be the mass of solution? It will be 18 plus 2, right? So it is 2 divided by 20 multiplied by 100. Clear? So this is how you calculate your mass percentage. So now let's move on with the second concentration term, that is mole fraction. So what is mole fraction? It is defined as the ratio of number of moles of a particular component to the total number of moles of your solution. So what does the equation says? It is number of moles of component divided by total number of moles of components. That means if you have to find out the mole fraction of your solute, then number of moles of solute divided by total number of moles of the solution. If it is solvent, then it becomes number of moles of solvent divided by total number of moles of your solution. So for example, let's take a binary solution. Binary solution means it consists of 2 components. That is, let's take the example A and B. Okay, A and B are my solute and solvent. So what will be the mole fraction of the component A? Yes, it is number of moles of A. Yes, I have to find out the mole fraction of A, right? So it will be number of moles of A divided by number of moles of A plus number of moles of B. Clear? Now what will be mole fraction of B then? Yes, it will be number of moles of B divided by number of moles of A plus number of moles of B. Yes? So that means mole fraction of A plus mole fraction of B will give you 1. Right? So this is mole fraction. Now let's do an example for this. Yes, 23 gram of ethyl alcohol is dissolved in 54 gram of water. You have to calculate the mole fraction of ethyl alcohol and water in solution. So you have to find the mole fraction of your ethyl alcohol as well as water. So from where do you begin to do this numerical? So you know that what is the equation for finding the mole fraction, say, let's say, of ethyl alcohol? It will be, yes, number of moles of, let's say it is A divided by number of moles of A plus number of moles of B, right? Yes, so is number of moles provided here? No, right? So first you have to begin by calculating the number of moles of your ethyl alcohol and number of moles of your water, right? So how do I calculate the number of moles of my ethyl alcohol? Yes, how do I calculate number of moles? What's the equation? It is mass by molar mass, right? Mass by molar mass. Yes, so mass is given here, that is 23 gram of ethyl alcohol. What is the molar mass? You have to calculate the molar mass, right? So this will be equal to 23 divided by, what is the molar mass for ethyl alcohol? Let's see, C2H5OH, right? So it is 12 into 2 plus 5 plus 16 plus 1, which will give you 46 gram, right? That will be my molar mass, right? So 23 divided by 46 will give me 0.5 moles. Clear? Yes. So now I have to calculate the number of moles of water. Yes. So how do I calculate it? It will be equal to mass. What is the mass given here? 54 gram of water, and molar mass of water, you know, it is 18, right? So that will give me 3 moles of water, right? So we calculate the number of moles. Now you have to calculate the mole fraction, right? So mole fraction for C2H5OH, that is your ethyl alcohol, will be equal to number of moles of ethyl alcohol by total number of moles of the solution, right? So what is number of moles of ethyl alcohol? It is 0.5 divided by 0.5 plus 3, right? That will give you 0.142. Yes, that will be your mole fraction. So now how can you calculate the mole fraction of water? It will be equal to 3 divided by 0.5 plus 3, right? It is number of moles of your water divided by total number of moles of solution. Yes, so that will give me 0.857. That will be your mole fraction. So I hope mole fraction is clear for you. So now let's move on to our third concentration term, that is molarity, which is represented by capital M. So it is defined as the number of moles of solute dissolved in 1 liter of solution. So it is the number of moles of your solute which is present in 1 liter of your solution. So what is the equation? Molarity is equal to number of moles of solute, which is represented by N, divided by volume of solution in liters. Yes, so I can also write it as, yes, number of moles. What is the equation for finding number of moles? It is your mass by molar mass, right? That is the equation to find number of moles. So we are talking it in terms of solute. So that means if A and B are my two components, A will be my solvent and B is my solute, right? So how can I represent it? Can I represent it as WB by MB into volume in liters? Yes, can I write it as this? WB by MB is the number of moles divided by volume. Yes, you can write it in this way. Now, if your volume of the solution is given in milliliters, what do you have to do? You can also represent it as WB by MB into volume multiplied by 1000 if it is given in milliliters. So what did I do here? I just expanded your number of moles of solute and wrote it in this form. So either of this equation you can use for your numericals, right? So for example, 0.25 molar solution. Yes, how do you spell it? M represents molarity, that is 0.25 molar solution of NaOH, means that 0.25 moles of NaOH is present in 1 liter of solution. Clear? Yes. Now let's do a question on this. Calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solution. So what is the equation that we know? Molarity is equal to number of moles by volume of solution in liters, right? So what is given here? Calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of your solution. So number of moles is not given here. You have to find out the number of moles. So how can you find out number of moles? Given mass, that is 4 gram by molar mass. Molar mass is given? No, right? So you can find out molar mass of NaOH, which is 23 plus 16 plus 1, which will give you 40. Right? So that is 0.1 moles. So now we obtained the number of moles. Now what we have to find? We have to calculate the molarity. That will be 0.1. Yes, number of moles present in 1 liter of solution, right? So the solution, the volume of solution is given in mLs here. So divided by 250, what do you have to do? Yes, multiplied by 1000. Clear? So which gives you 0.4 molar. So yes, you calculate the molarity of solution. Clear? Yes, it is given in ml. That is why I multiplied it by 1000 in the numerator. Clear? Yes. Now let's move on to the last concentration term, molality. So now what is molality? It is defined as the number of moles of solute per kilogram of solvent. Yes, so you have to be very clear with molarity and molality. Molarity is the number of moles of solute present in 1 liter of your solution, and molality is the number of moles of solute present in 1 kilogram of your solvent, right? Not solution, 1 kilogram of your solvent. Yes, molarity is in terms of volume and molality it is in terms of mass, right? So how can you write? Molality is number of moles of solute divided by mass of solvent in kg. How we wrote in the case of molarity, same way we will write in the case of molality as well. So it will be number of moles is WB by MB, right? Now what is there? Divided by mass of solvent, right? So what is your mass of solvent? WA, right? A represents solvent and B will be your solute. Yes, if it is given in kilograms, right? If it is given in grams, your equation becomes WB by MB multiplied by WA, and in the numerator 1000 will be there if it is given in grams. If it is in kilogram, you can use this particular equation. Yes. Now let's take an example for this. Molality. Okay. So the density of 3 molar solution of sodium chloride is 1.25 gram per milliliter. Now you have to calculate the molality of the solution. Yes. How do you proceed with this? The molarity of the solution is given. Yes. 3 molar solution. Yes. Molarity is given. So what is molarity? Molarity is the number of moles of solute present in 1 liter of your solution. So 3 molar means 3 moles of NaCl. Yes, you know the solute is NaCl. 3 molar means 3 moles of NaCl is present in 1 liter of your solution. Right. So this is what is meant by 3 molar solution. So moles is given here. Now what do you have to find? You have to calculate the molality of the solution. Yes. So we know that the equation to find molality, yes, represented by small m, is number of moles of your solute divided by mass in kg. Right? Mass of your solvent in kg. Right? So number of moles we were able to calculate. Now what is mass of your solvent? It is not given in the solution. So now we are going to find out the mass of your solvent. So you know that what is the equation to find number of moles? It is mass by molar mass, right? Mass by molar mass. Yes, you do not know the mass of the solute that is given here. You know the molar mass. You can calculate the molar mass of sodium chloride, but number of moles is also available. So first you can calculate the mass of your solute. Mass of your solute will be equal to, yes, what is N? Number of moles, right? So it is given as 3 multiplied. What is the molar mass of your sodium chloride? Yes, you can calculate it. Sodium chloride will be 23 plus 35.5, which will give you 58.5, right? So this will be the mass of your molar mass of your sodium chloride. So it will be 3 into 58.5, which will give you 175.5 grams. Yes, so you calculated the mass of your solute which is present. So now we are moving on to finding the mass of your solution. Yes, what else is given here? Density is given. Yes, density is equal to 1.25 gram per ml. Yes, right? And the volume of the solution is also given, right? That is 3 molar means 3 moles of NaCl in 1 liter of solution. So your volume is also provided here. So how can you calculate mass? It will be density into volume, right? You know that density is equal to mass by volume, right? So what will be my mass? Density into volume. Yes, that is 1.25 multiplied by 1000. 1 liter means 1000 gram, right? So that will give me 1250 grams. Yes. Now what did we calculate? It is the mass of your solution, right? Clear. Now what did we do? We calculated the mass of solute and mass of your solution. But exactly what is that we require here? It is the mass of solvent, right? So how can I calculate the mass of my solvent? Mass of solvent will be equal to, yes, mass of your solution minus mass of your solute, right? We know that mass of solution is equal to mass of solute plus mass of solvent. So mass of solvent is mass of solution minus mass of solute. That is, what is the mass of solution? 1250 minus the mass of solute we already calculated. It is 175.5 grams, which will give me mass of solvent as 1074.5 grams. You obtained your mass of solvent. Now, what is it that we have to eventually find? It is molality, right? So, what is molality? It is number of moles of your solute by mass of your solvent in kilograms, right? So, number of moles we already knew, that is 3, divided by mass of the solvent we calculated, it is 1074.5. It is given in grams, means I have to multiply it by 1000 in the numerator, right? So, which will give me the molarity as 2.79 molar. Yes, I hope the question is clear for you. Let's quickly revise it. Yes, in the question 3 molar was given. So that means 3 moles of NaCl in 1 liter of solution. Then we calculated the number of moles of your solute, from which you were able to calculate the mass of solute. Yes, and then you calculated the mass of solution because the density was given. Yes, then from there you were able to calculate mass of solvent. Yes, that is mass of solution minus mass of your solute, which will give you the mass of solvent, and you have to just put it onto your equation. That is, molality equals to number of moles of solute by mass of your solvent in kilogram, right? So it was given in grams, that is why I multiplied it by 1000, which will give you the answer. Yes, I hope the question is clear for you. So that's the end of your unit, some basic concepts of chemistry. I hope the concepts that we have discussed in this chapter is clear for you. So let's meet in the next section with a new chapter. So that's all for today. Thank you.